Imagine being able to completely port your development environment alongside your code base in the repository. In other words, whenever you clone a repository, you don't need to worry about dependencies, missing packages, or installation at all. Development containers, or dev containers for the close friends, is a very extremely convenient way to create a fully portable development environment across people that want to work on your project, even yourself if you have multiple machines you want to work in the same repository. Today, I will show you how to set up your own development container to build C++ projects in any machine. Hi, my name is Marcos and this is Practical Software. Past videos, I have been in a kind of a manual way, actually using development containers to showcase some of the software engineering concepts. But thankfully, there is a way simpler way to set up your own development container yourself with a Visual Studio extension. All you have to do is to configure a file and possibly a Docker file to sort out all the development environment for you. Dev containers leverage all the good stuff that comes with Docker. All the dependencies are already inside an image, so you can immediately build an application right away. Those images can be shared for your whole project or your whole team very quickly. The configuration is already part of the repository, so actually nobody has to do anything. It already comes with the repository itself. And any machine that has a Docker engine is completely capable of building an application. And nowadays, every possible machine has its own Docker engine runtime. So, as a practical example, we will set up a C++ project with a ready-to-go environment. As a bonus, I will introduce you to some very useful practice, also very often used in industry standard projects. Recall from the past videos that properly setting C++ projects were a bit tricky. So we had a lot of stuff to figure out. So we have a debugger, CMAKE, testing libraries, mocking libraries, and much more. And everything has to be ready for the build time. This is where the power of the dev containers comes in place. When a repository is configured with a dev container, you literally don't have to do anything. It can go right away to the coding part, which is the fun part. Side note, I have already worked in some projects before in my experience that took weeks to get started before you write your very first line of code. And this is not good, not for the company or for the developers. At the same time, also participated in projects which had a really nice development environment. So all I had to do was clone a repository and turn on the dev container extension, and I was already able to actually perform changes to the code, which is really nice. It felt really efficient. All right, to really demonstrate the capabilities of dev containers, I have already set up a repository with the dev container configuration checked in. So theoretically, all I have to do is to clone this stuff, press a button, and I should be able to immediately build my application. So let's get practical. This is Visual Studio Code, and this is that extension that I spoke about, dev containers from Microsoft. This is the only extension you're ever gonna need for this setup. So make sure that you have this installed. You have to have it running in your background. So let's get to it. I'm gonna clone this repository, this very famous repository I spoke so much about, that has all this dev container thing running. So let's see how it goes. And this is it. So I just cloned it. Now I just have to make sure I open in Visual Studio. So Command-Shift-P, open folder. All right, we are good. So you can ignore this, but not this one. So have a look at this prompt. So Visual Studio Code is already aware that this is a dev container. So it's prompting you, should I open this inside the container itself? So we're gonna go there in a few moments. Let's have a look at the contents. The reason it knows is because of this small folder and this file. And the file is really simple. So you give a name to this development container, whatever, and you can either provide an image or a build for a Docker file build. So the image can be anything. It can be a base image coming from the internet or something you have in your own local machine, or you can provide a Docker file with a custom-made Docker container or image for your particular application. And you can also provide extensions that are gonna be built in the container itself. So here we see this C++ pack, which is exactly this one. And I can just add to dev container. This is how you install or tell VS Code to install this in the container. If I do this, it's already there, and the Clang-format. Clang-format is a very nice tool. You'll see a little bit more in a few moments. So back to the JSON, and you can also provide settings for particular extensions that are already installed. So for example, here we installed CMAKE, and I can provide some, let's say, nice to have configurations for VS Code itself. So this is to make a nice status bar here in the bottom, and this is just to load the compile options for IntelliSense. So this is enough, and you see why. And finally, the Docker file itself. So I'm basing this image from Ubuntu Mantic because it has a C++ 20 from GCC 13. And this is where we tell that this container should have all these dependencies. It's going to be installed in the container itself, in the image, and the container will have it available for us. So if my application, for example, in CMAKE uses Google Test, the reason it's able to find Google Test is because it belongs to the container, Google Mock. So I also install a debugger. I install Clang-tidy, another very nice tool, Clang-format. And so notice that everything that you ever need to application, we didn't see it yet. This is all we need. I didn't have to tell anyone, hey, by the way, the README file, you should install these dependencies, you should do this and that. No, it's there. It's just reading a file, and you figure out, okay, this should be enough to build this application. And now we do the magical part. If I go to that asked me about in the beginning, so this is a dev container operation to open the folder in the container. Let's just do it. And now the magic. So here at the bottom, it was really fast because the image was already cached in my machine. If you were to build this image in your own machine and reproduce the same steps of this video, it's probably going to take a bit longer because it's going to build that actual Docker file that we just... So I'm inside the machine now, and CMAKE inside the container is asking me, oh, which compiler do you want to use? Because I could just pick one. And this is it. My dev container is ready. So have a look at this. So I have a main file, an include file, and the CMAKE describing my project. So we saw CMAKE a few videos ago. So CMAKE is describing my project. And all I have to do to build this thing is to press this button. And I just built my application. My application depends on Google Test and this algebra library, Eigen, but this already belonged to the container. I didn't do anything. I could immediately build it, which is really nice. I can select the target. So CMAKE parses my application for me. I can tell, oh, I just built a test, just built my library, or just built my main executable. And I can also, the container allows me to also prepare the tests. So I made sure in the dev container setup that the CMAKE extensions would parse the tests for me. It's part of the expansion pack, which is part of CMAKE in turn. So look at this. I immediately was able to, I didn't have to install anything. Let's say you have a project, people share this, you just cloned it, and they told you fix this test. And you could just press this button, search for the tests, press play, and it's gonna tell you, oh, this test is the test, oh, 37, okay, oh, this is 74. You can just run it again, boom, works. CMAKE, you can cherry pick this build, you can build it again, you can just run it, you can select the target. I'm gonna run main, this hello world application. Yeah, boom, it works out of the box. This is inside a container. I didn't have to install any host machine. So if I can just do this, for example, just to show you that everything is working properly. 1 and 0, perfect. Notice, IntelliSense auto-completion mechanism is already ready for you. So I can just navigate and look at the documentation and have auto-completion for me for this specific, like this is vector 2, I can also have a vector 3D. So you see, everything is really ready for us. You can immediately build tests because Google Test is already inside it. And that's it, guys and girls. Yeah, I'm just pressing buttons. I didn't do anything. Development container did everything for me. Now let's have a look at those two bonus features I spoke about, which are Clang-tidy and Clang-format. So Clang-tidy is a very famous C++ linter that does static analysis. So it looks into your functions and variables and tries to possible problems or issues with your code. It knows, for example, oh, you should pass this as a constant ref or not as a value. You're not using this variable, you should just throw it away and other stuff. And the good thing about it, is that many industry standard projects So people that care a lot about their products, the software products, they use Clang-tidy a lot. So I think it's a good opportunity for us to have a look at it as a CMAKE option, for example, and just delve into it. This is how you would configure that. So you can either set it as an option, meaning that you have to explicitly tell CMAKE to either use it or not. In case you said yes, then it does the checks for you. So CMAKE has a built-in way to deal with Clang-tidy, which is just setting this variable. So this is where you would set the executable. Clang-tidy is executable, and then you just pass the arguments, like different ways to pass arguments, more scalable ones. But for the purpose of just explaining and showcasing, this is enough. You can also tell Clang-tidy to issue errors instead of warnings. So you enforce your build system to error out if something is wrong. And this is really useful when you have a build system in a pipeline, for example, and you want to do those checks before something gets merged in your code, in your main branch, for example. And this is all. I'm also passing some compiler options to enforce more things, so you could also add stuff to the list. Yeah, again, if you look at the Docker file, I installed Clang-tidy, so this is the reason why this is possible. Clang-tidy is an executable. It has to be inside your system before you can use this. And then all you have to do, and I also put in a message in CMAKE syntax to, it's gonna print out. So one way to do it is just go to this build folder, dot because the make list is on a parent folder, use Clang-tidy equals on. This is enough to trigger this option, this conditional. If you set off, we're not gonna see the print anymore. This is one way to do it. Another way is to go into the CMAKE settings. So let me turn off for a moment. If we go to CMAKE settings, click on this gear thing, we're gonna filter for args, and we can pass configure arguments to CMAKE as well. So let's do this. So let me pass using the CMAKE GUI, use Clang-tidy equals on. Now, when I do configure, so Command Shift P, configure, I'm using Clang-tidy once more, and I can just disable this option. It's cached in, off, configure, it's turned off, then I can remove it. So let's just enable this again. And now let's see what happens. I'm gonna try to build, and if we look again, I should see errors. Now, why? Because there's possibly some mistakes in our code. There's a good chance there are mistakes. Look at this. Error. Parameter val is copied for identification, but uses a const reference. Consider making the const reference. Let's have a look. Look at this. So without Clang-tidy, this code will compile fine, but I turn this on, and then it's complaining, which is a good thing, because I want to make good code. I want to see this linter thing doing its job. So he says I should make this a const ref. Fair enough. And this variable is too short. Okay, let's try to build again. You will notice also that the build is going to be a bit slower because, yeah, it's a trade-off. You're checking things and you're enforcing other things, and the compiler has to take a little bit more time to figure out the stuff. Looks like it builds. Great. It's going to do linting for your tests. You see, this is a very convenient way to develop your own C++ project. All dependencies are there. Everything is really there for us, and you can use this if you want it as a reference, of course. And the last thing is Clang-format. So once more, you're gonna see in the Docker file there is something called Clang-format. Clang-format is a tool that's meant for formatting, and the way you use it, there are also two ways. You can either, of course, you have to install it. So I have it here. It's on my machine, Clang-format version 16. One way to do it, providing a Clang-format file. It doesn't have to be that big. So this is just a Clang-format dump config. It's going to produce some basic configuration. So all I did was dump config. There are different styles of Google, Microsoft, Clang, LLVM, and more others, and then produce this for us. And one way to use it is using that dotted extension that is installed in the container called Clang-format. By the way, here it lists all the extensions inside the container, and this is one of them. So all it does is simply, it connects your formatting feature of VS Code to this Clang format. So it's gonna enforce the formatting of your file. So instead of doing this, for example, if I press Option Shift F for Mac, it's gonna adhere to this, let's say, constraints. So let's say I wanna have less columns, meaning less width or line sizes. I can just change this file. I can run again the formatter, and it's gonna honor that contract listed in this file. I can also use another configuration, a style, Microsoft, I think it's one of the styles. So I should see a different one. Yeah, Microsoft. And if I try to format again, it's gonna use a different formatting standard. Now, this is one way to use it. Another way to use it is using the terminal. You can make a script. I can find every file that is named with the CPP or with the name x.h. So it listed all the files. I could ignore also the build folder. And then I can pass Clang-format like this, just to be really sure. Yeah, it's taken a while because I didn't filter properly. So yeah, you can just invoke the tool, and you can make a custom command for the formatting. So it also runs every time you build it. This is one way to do it. So you can add a custom command. You can specify the kind of a role for a specific target. So for example, every time before I do the build for this main target, I want to run the command Clang-format, and those are the arguments. I don't think this is needed. And then every time I build it, I'm gonna run Clang-format on every CPP file and every H file in those specific two folders. Yeah, let's break that standard a little bit. Yeah, this is enough. If I do the build, yeah, it's formatting the code automatically for me. And this concludes the video. Now you know how to use dev containers, and even better, how to use them for C++ projects. You know now how to use Clang-tidy and couple this with CMAKE. You know how to use Clang-format. So I really hope you learned something new today in this video. I hope you make use of this in the future, and thanks for watching.